Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on November 6th, 2025, about 3 days ago. The headline result is striking. A 7 billion parameter video model fine-tuned on just 25,000 simulated examples reaches 44.4% on a tough spatial benchmark, beating GPT-4o at 34.0% and a larger LLAVA video 72 billion at 41.2%, and it nearly matches Gemini 1.5 Pro at 45.4%. Even 5,000 targeted examples hit 42.5%, edging Gemini 1.5 Flash at 42.1%. The paper is titled SIMS 5, Simulated Instruction Tuning for Spatial Video Understanding, and the implications for sim to real training are quite significant. Alright, the introduction set the stakes. Figure 1 presents the core idea and the headline effects. The left side shows a simulator-driven pipeline that renders 3D layouts, logs observation-level metadata, traces camera trajectories, and programs spatial question-answer pairs. On the right, the benchmark panels report sizable gains, with LLAVA video up about 8% in domain and about 5% for one vision, plus boosts on OpenEQA and MME Real World. So Figure 2 details the end-to-end pipeline that produced the targeted training data. The full diagram shows scene generation, trajectory capture, dense annotation extraction, and spatial question creation, which together ensure perfect ground truth. The scene generation panel uses AI2 Thor, ProcThor, and Obgiverse to build diverse 3D rooms. The trajectory capture panel plans paths, simulates movement, and records videos. The spatial QA module filters to visible content, generates types like size, distance, and order, and performs quality checks. Well, Figure 2 outlined the data pipeline. Figure 3 now illustrates the question space that pipeline produces. The top row organizes prompts into 3 pillars, which are measurement, spatiotemporal tracking, and perspective. Examples cover absolute distance and room size, first appearance order across frames, and viewpoint-based tasks like object counts or left-right direction. Each prompt appears in open-ended and multiple-choice formats, with plausible distractors, so training targets precise, unambiguous supervision. The film strip provides the simulated video context. So the previous figure mapped the question space. Figure 5 quantifies data efficiency. The left plot shows VSI bench accuracy rising quickly as samples increase, with the 3Q minimal mix beating the baseline at every scale, hitting about 43% at 5,000 and roughly 44% at 25,000, which nears Gemini 1.5 Pro. The dashed lines mark comparator models. The right table lists the baseline mix composition, mirroring the test set's question types. Alright, the previous figure highlighted data efficiency. Table 1 reports the head-to-head results on versus SI bench. The LLAVA video 7 billion model with 25,000 SIMS v3q reaches 44.4%, which surpasses GPT-4o at 34% and the larger LLAVA video 72 billion at 41.2%, and nearly matches Gemini 1.5 Pro at 45.4%. The absolute distance column shows a jump of about 20 points. The appearance order column on the far right shows a striking gain of about 26 points. So the previous table established headline accuracy. Table 3 reports how those gains carry over. The table shows strong transfer. LLAVA video 7 billion jumps about 9% on OpenEQA and about 5% on MME Real World, while Ego Schema rises about 2% and Video MME stays roughly flat. The corresponding One Vision model shows smaller but consistent boosts, about 1% on MME Real World, with near zero change on Ego Schema. These results indicate that spatial tuning maintains general video skills while improving embodied and real-world spatial reasoning. Wrapping up, 2 takeaways stand out. First, a small 3Q mix of measurement, perspective, and temporal tracking drives sim to real transfer, beating much larger models with just tens of thousands of examples. Second, spatial tuning improves embodied and real-world tasks while preserving general video skills. That is it for the AI Research Roundup. I am Alex. Thanks for listening.